All right, so we're doing the, what's that school? What's the name of the school? I think it's TKSS. Right, so question 1, part 1 is okay, but part 2 not okay. Have you watched the video already?
Yeah, I saw the video you sent and also the working you did.
Yeah, so after, okay, let me bring up the working. If I can find it, should be this one, right? So just remember, always part 1 differentiate means you need to use the answer from part 1 to integrate in part 2. So over here, the trick is you don't try to factorize it. Like if you try to factorize it like this, it becomes what we call a product. Okay, product of 2 different functions. You try to integrate a product, not so easy. Not so easy. What you should do is to leave it as 2 separate terms, which is basically these 2 terms, right? So that you can integrate both sides, then you can integrate term by term, sort of distribute the integration. Not exactly, but you get the idea, right? Integrate the first term plus integrate second term. One of them will always be the one that you want. The other guys will be something that is already part of the final, going to be part of the final answer, or can be easily simplified from an integral to an actual expression. Does that make sense? Are you following so far?
Yeah.
Can, okay, yep. So I already sent you this file, right? You can go and download it and read it in more details. But the basic idea I want you to remember is use the answer from part 1, 2 separate terms. Then you integrate both sides, but you have to integrate term by term. And then you make the one that you want the subject. In this case, 2 times x times e power 1 minus 2x as the integrand. A thing in between the make and the dx. This one. Make it into what is requested by the question in part 2. And for definite integral, you just have to sub in the limits, 1 and 0. Right? Oh, did I not sub in the limits? Oh, I did it the next page, right? After you get the answer for the indefinite integral, you don't need the plus c, sub in the 1, sub in the 0, subtract, and you'll get your answer. Is that okay?
Yeah.
Yeah. Go watch the video if you want to have more detailed explanation. So then what happens next? After you answer part 2, you need to look at part 3. So determine which one of the 2 graphs below is that of y equals 2x times e power 1 minus 2x. Explain your answer. So the trick here is to realize that there's this point and this point. What do we call them?
Max, min? No.
Max and min, exactly. So how to find maximum, minimum?
That star.
Yes, that star. What's that star?
Differentiate.
Differentiate.
Equate to 0. Solve. Then
0.
table.
And then table. Table is to determine the nature, max or min. Okay. So let's just do it together. Maybe I'll do it on the question paper easier. So y equals to 2x times e power 1 minus 2x. Differentiate this. So what rule do you need to use?
Product rule. Yeah.
Yeah, for the 2, you can factor out first. Then you deal with the remaining part, x multiplied by e power something. So draw a huge bracket, keep 1, differentiate the other. Differentiate e, what do you get? E power.
You get the same thing, and then times negative 2.
Make sure you got the open and close bracket around negative. Okay, then plus
it's just e to the power of 1 minus 2x
times derivative of x, which is 1. Okay, so of course you don't need to put the times on. Okay, simplify a bit more. Then you get 2 times negative 2, negative 4. So negative 4x times e power 1 minus 2x. The next one, positive 2 times this other guy, plus 2 e power 1 minus 2x. Then you have to say for SP. Stationary points, set dy by dx equal to 0. What do you get at the end? You just get that expression, the derivative equals to 0. Wow, how to solve? So difficult, never see before. That's when you need to use your factorization skills. Can you see that this e power something and e power something is repeated?
Yeah.
And it's separated by a plus sign. So they are common common factor. So we can factor out the e power 1 minus 2x. Okay, times, let's draw a square bracket, get negative 4x plus 2. Close square bracket. Okay, actually, can use round bracket also. Same thing, same thing. So now that you have something multiplied by a second thing equals to 0, what can we conclude?
What can I conclude?
Like x minus 1 times x plus 3 equals 0. What can we conclude? Something multiplied by something.
Two answers. What? No.
Yes, two answers. This first guy equals to 0, or the other guy equals to 0. Dot, dot, dot. The dot, dot, dot is x minus 1. The dot, dot, dot is x plus 3. Okay? So over here, you have e power 1 minus 2x equals 0, or minus 4x plus 2 equals to 0. Okay? Following so far?
Yeah.
Okay, but then this guy, e power something, how does the graph of e power something look like? The e power x. Like this, right? Upwards. What about if I now have e power 2x?
It's the same, but it is steeper.
Yeah, if it's what e power 2x this time, it's steeper. Okay, like this. Then what if I have e power negative 2x?
Then it goes the other way.
Can you draw it for me? Okay, got it. Yes. So basically you go the other way. Reflect about the y-axis. So this is y equals e power negative 2x. Then here you have a plus 1. Okay, this one, you can think of it like this. Do you agree that e power 1 minus 2x is really just e power 1 times e power negative 2x? Right?
Yeah.
Same base, different power, multiply, you add the power. 1 plus negative 2x plus a negative, don't need the plus sign, 1 minus 2x. Okay, then e power 1 is just a number, right? It's just like approximately 2.7. So it's like 2.7 multiplied by e power negative 2x. What happens when you have a positive coefficient multiplied to an expression? What happens to all your y values from before and after? Times 2.7, right? So essentially what happens to your graph? It just becomes even more steep, right? Very good. Let me change to a different color. Maybe I'll use purple. And over here, I'll also use purple. So running out of space, let me just zoom in a bit. More like something like this. So that will be your y equals e power 1 minus 2x, right? And the key idea here you need to realize is that this purple graph, does it ever touch the x-axis?
No. Wait.
Oh, exactly. No. Cannot touch x-axis. If you wanted to solve for x, what you could would be doing if you blindly follow your algebra rules is, e power something you bring over means you take a logarithm, right? So you have to ln 0, right? What happens if you ln 0?
Ln 0.
Ln 0. Ln 0. What's ln 0? How to draw ln graph? Can we ln 0?
No.
No. Why? Because the graph will just approach closer and closer towards x equals 0, but never equals to 0. You type in a calculator, you get math error. Okay. So the conclusion here is no solution. Okay. You see exponential equals 0? Impossible. Clear?
Yeah.
Okay, but there is still the other half, minus 4x plus 2 equals 0. Bring the 4x over, you get 4x equals to 2. You get finally x equals to 2 over 4, which is 1/2. Okay? Good? Okay, x equals half not enough. We are only done with the second step of that star. D. Now and then it's E. And then after that, we managed to solve, right? Differentiate, equate to 0, and solve for x. What do we do next? Hubble table. Okay, draw a table. So we're gonna have x dy by dx. Actually, I don't really want the dy by dx expression. I just want the sign of dy by dx. The sign, plus minus, or 0. And then I draw a tangent line just for illustration purpose. Okay, so x equals, let's see, we start off with a half. Then on the left, we have half, but with a minus sign, slightly smaller than half, and half with a plus sign, something slightly bigger than half. Slightly bigger, you can use maybe say plus minus 0.1, 0.01. Okay, so let's just type in a calculator. This one will be a 0, but what happens if you type in something slightly smaller than half? So let's say 0, 0. Let me think, 499. Or just 49. Sub in this into the expression for dy by dx. This guy. Example. What do you get? Are you typing?
Yeah.
So pick a value slightly smaller than half. In this case, I pick 0.49 as the x. You sub in into the dy by dx over there. Then you try to get the SIGN sign of that expression after you sub in x equals 0.49. What do you get?
I get math error. Wait, no. Wait.
Do you need me to show you how to type this?
I get positive value.
Yeah. Yes.
0.04080181.
Same answer. Very good. Same answer. I also got the 0.0408080536. Okay. And make a smart guess. What do you think if you sub in with a number that's slightly bigger? What will you get?
You get a negative number.
You can verify that on your own after class. But that has to be it. Why? So example, you can pick x equals 0.51, sub in into this expression, you get positive. So if you now draw the tangent, positive slope will be upwards. 0 will be horizontal line. Negative will be downward slope. Okay, good. So you can see that there will be a curve that fits nicely underneath it, and that's a dot point.
Maximum point.
Yeah, maximum
so
point.
It's the first one.
Yes. Therefore, graph 1. Okay.
So if you did it and then you got minimum point, then you know it's graph 2.
Yeah.
Oh, okay.
Right, that's a key characteristic. Is there a faster way to do this? Is there a faster way? Yes.
I don't know.
Let's take a look. What happens if when with this part of the x-axis, right, the x values are positive or negative?
Positive.
Positive. So with this graph above the x-axis, are the y values positive or negative when x is positive?
Positive.
How about graph 2?
A negative.
Negative. That's another key distinction between them, right? So if you just sub in a positive x value and you test for one example, if you get a positive value, then it's graph 1. Let's say, for example, x equals to 1. Y equals to 2 times 1 times e to the power of 1 minus 2 times 1. So it's 2 e power 1 minus 2 times 1, it's negative 1. E power anything is always positive. 2 is positive. Positive times a positive gives you positive. So graph 1. This point here, 1 comma 2e power negative 1. Which is same as 1 over 1 comma 2 over e. Okay,
Mm.
good. That's another way to identify. Yeah, the graph 2 lies entirely below x-axis, so therefore y coordinates must all be negative. Whereas for graph 1, it's the other way around. For positive values of x, all of the entire graph is above the x-axis, so all of the y coordinates are positive. In this case, 2 over e is positive, so it must be graph 1. Okay, next. Let me know if you got any questions. I'm gonna move on.
Okay.
And good. Your question 2 was well done. Very good. Part 2, perfect. Very good. Nothing to say. It was good. It was good. Okay. Question 3. Oh wait. Let me. I can't remember the question. Let me take a look. Question 2, part 1. Prove this. Okay. Hence solve. Part 2. Do you solve part 2? Let me see. Right. You did. You did. Okay. How about question 3? Show this one. Show that it's a factor, then express as sum of 3 partial fractions. Yeah, it was very well done. Good. Good.
It took very long.
Too very long.
What?
Then
Just that
practice is the
had-
only solution.
I had to go find which video, and then like I had to rewatch, and then like I had to do some other questions. I was like, oh, okay, now I can do it.
Oh, you can leave a comment in the YouTube. Like, what is the name of the topic? I'm not going to do it. You can do it yourself.
Okay,
And
okay.
you can find
I'll
it.
be referencing a lot, anyways.
Okay. And how about question 4? Let's see. Part A. It was good. Okay. For part B, also okay. Nothing to say. Very good. Your logarithms. Can remember all the rules. Question 5. Derivative and final expression. Was it okay? Let me see. I'll take a while back. Yes, it was okay. 6 part 1. This one no attempt. 6 part 1, 6 part 2. Let's take a look. So even though it says show question, all they're really asking you to do is just differentiate. But the reason why they ask you to show is because after you differentiate cosine and sines, you'll end up back with cosine and sine. And you can have a lot of different trigo identities. So there's a lot of possible different answers. So this is maybe the question setter was just trying to be lazy. They want the easier time to mark. So they have to standardize the final answer, the format of the final answer. That's why they have a show. It's something times sine of something theta. Okay, so you must end up with this format. Sine of something. Don't give me tangent, don't give me cosine, even though they are identities. Okay, so let's just do it. Did you understand what I was saying?
Yeah, I know what you mean.
Yeah, you get this. Okay, so just differentiate term by term. Differentiate a sum means you can differentiate the first guy plus differentiate the second guy. If it's a minus, then you differentiate the first guy, then minus differentiate the second guy. The derivative. Okay, so how do you differentiate cosine power 4 theta? First thing you must realize is cosine theta is an inner function, bracket to the power of 4 is an outer function. Outer, inner. What do you do when there's outer and inner?
Chain rule.
Chain rule. So differentiate power 4, what do you do?
3.
Bring down. Yeah. What was the coefficient? Bring
4.
Bring down the old power 4. The base copy and paste. -1 to get the new power. 4 minus 1. Yes, okay, so 4 cosine theta bracket power 3. Or if you're more efficient, you can write cos cube theta. Then times, yes, differentiate the inner function cosine, you get cosine. Plus, I think you know how to do the sine power 4 now. Try. 4 sine theta. D outer done, now you D inner, so is the screen lagging? Oh, okay. Good, yes. So 4 times sine theta base, power reduced by 1, 3, 4 minus 1 is 3. Then you times the derivative of the inner function. So differentiate sine, you get cosine. Okay, good. So now notice that this is not in the correct form they want. They want P times sine of something theta. Also, the coefficient here, Q, may not be 1. Most likely it's not 1. Also, it's not sine theta anymore, it's sine 2 theta, double angle identity, or sine 3 theta, that kind of thing. Right? So let's just simplify this a bit. I like to write it as -4 sine theta cos cube theta. Is that okay? Cos cube, can plus 4 cos theta times sine cube theta. Any common factors? Do you see any common factors?
Like sine and cosine.
How about the numbers?
Oh yeah, 4 also.
4. Okay, so 4, 1 copy of sine, 1 copy of cosine. Factor out. What am I left with? 4 take away, sine take away, 1 copy of cosine take away. I'm left with 2 copies of cosine, but don't forget the minus. So minus cos square theta. Is that okay? Plus, take out the 4, take out the cosine, take out 1 copy of sine. You're left with what? 2 copies of sine, so sine squared. Okay. Cos minus cos squared plus sine squared. Oh, is it equal to 1? Is it equal to 1? You see, cos squared plus sine squared. Then you introduce your own bracket and you say it's 1, so therefore minus 1. Correct?
Yeah.
Wrong. Let me ask you a question. Minus 3
Wait,
square
no.
plus 4 square. Is it equal to minus bracket 3 square plus 4 square?
Because it's not minus bracket cosine squared theta plus sine
Very
squared.
good. Yes, don't introduce your own brackets. The minus only pairs up with the cosine square. Don't introduce your own bracket. This is definitely not equal. I better put a slash here, if not I confuse you. A slash. No, not equal. Boom. Bad. Wrong, huh?
Sub into cosine square 1 minus sine square theta.
Then multiply the minus in, you end up with 2 sines. You end up with
Wait, or is it better to sub into this one 1 minus cosine?
Or maybe there's an even better identity. What if I told you to factor out a -1?
Out a -1.
So -4 sine theta cosine theta. What am I left with?
Cosine square theta minus sine square theta.
Does that sound familiar to you?
No.
No. Okay, I show you. Scroll up. Cosine square theta minus sine square theta. Cosine square theta minus sine square theta.
Cosine square theta minus sine square theta. Or cosine 2a.
Yes, but not a lah. It's theta. Change the a to theta. Okay, can. Yeah, this one pattern recognition lah. There's 3 formats for the cosine square, the cosine 2a. So you must practice until you get used to these 3. Okay, difference of squares. There's 2 cos square. There's a 2 sine square. Right. Power 2 drop down to power 1. Power reduction. Right. I briefly mentioned to you before. This one. And this one is power 2 becomes power 1 again. Okay, but anyways, yes, cosine 2a or 2 theta. Let me just replace this. So cosine 2 theta. Actually, is that useful? Maybe not so useful. Because what is the format they required? A single copy of sine. Single copy of sine. So maybe I'm leading you down a wrong path. Let's see how. Can. I see a way. I see a way out. When you have a sine multiplied by a cosine, does it remind you of anything? Any identities? Maybe I should have taken a screenshot of the identities. Give me a second. Screenshot. Go down. And then I will show you the identities. Okay, any identities you recall that has a sine multiplied by cosine? Our angle is P times sine of Q theta. Sine times the cosine. Which one? And we currently have a 2 theta.
Sine 2a.
Yes, over here, sine 2a is 2 times sine a cos a. And what a coincidence. 4 is divisible by 2. Right? You can factor it out. Factor out a copy of 2. So over here, how about if I rewrite it as negative 2 times 2? So what do you notice now? Okay, just nice, huh? 2 sine theta cos theta. So we can replace all these with sine 2 theta. Are you following so far? Good, good. So now we have a negative 2. Okay, don't be confused. I hope you're not confused. Negative 2 here is the negative 2 there. Okay, maybe I highlight the negative with a yellow sign as well. And this 2 times sine theta times cosine theta that I'm highlighting in light blue is the sine 2 theta. Can you see? Okay, so far? Good. So that means I now can just bring down the cosine 2 theta. I'll drop the brackets. Maybe I'll highlight it in a different color. If you stare at this very, very long, what do you notice? There's a minus, there's a 2, there's a sine, there's a cosine. Which is actually
it's the sine 2a thing, but it's like the 2 theta is now a.
yes. Yes. So what is your 2a now?
Huh?
If a is equal to what again? 2 times sine 2 theta times cosine 2 theta. So a is
2 theta.
2 theta. So what's 2a?
2a would be 4 theta.
4 theta. So what does the formula tell you here? Sine, you can simplify it down into sine of 2a. But 2a is?
Sine 4 theta.
So therefore, these 3 components becomes, let me just bring it down again. Sine of, what is it?
4 theta.
4 theta, very good. Don't forget a minus 1 in front. Now, can you answer the question? What is P and what's Q?
Negative 1 and 4.
Exactly, that's it. Okay, good. Okay, delete maybe I shrink it down, put it at the corner. Next, part 2. Yeah, there could be other ways that you solve to solve part 1, but I'm not sure. This is the only way I could see. Okay, moving on. 6, part 2. Hence, find the exact value of theta for which the graph blah 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 has a horizontal tangent for 0 less than theta less than pi over 2. By the way, pi over 2 is 90 degrees. But please follow the units given by the question, which is radians, pi over 2. So, what does it mean?
You can sub the negative 1 sine for theta
Equals to with?
equals to y.
No. Negative 1 sine for theta is the derivative of y. It's dy by d theta. This is actually equals to dy by d theta, where y equals to cosine power 4 theta plus sine power 4 theta. Okay? Is that okay? So what we just found from part 1, is that dy by d theta, so I should put a comma here, is equals to negative sine 4 theta. Okay? That's the main conclusion.
Okay.
Then what does it mean when they say over here horizontal tangent? Has a horizontal tangent.
Horizontal tangent.
The curve can look very, very crazy, very, very funny. But what is a horizontal tangent? Tangent lines are these guys, right?
Yeah.
Just touching. When is it horizontal?
Oops.
Horizontal. So in other words, what point of the graph has a horizontal tangent?
max point. Wait,
as well as
min points.
mean point, as well as
Uh,
what do you call it? What do you call this kind of
as
point?
well as
In
flux. Wait, no, in
okay, you got it. Inflection
inflection point.
Yes.
I swear I
Okay,
said it.
in general, what kind of point? Toilet paper.
Turning point.
Actually, turning point, not so accurate. Turning only maximum and minimum. The SP, superpower. No. Stationary.
Stationary.
Yes. A or E? A lah. A. E for eraser. It's the stationary in your pencil case. A is for the other guy, not moving. Anyways, stationary point, yeah. So here they're just basically telling you it's SP. So you just have to follow the same procedure as Desktop. For SP, differentiate already, that's from part 1. Then now you move on to E, equate to 0, but you must give a bit of reason for stationary point. Or actually just follow the question. For horizontal tangent, we have stationary points. So this implies for SP, we set dy by d theta equals to 0, which implies that negative sine of 4 theta equals to 0, right? Using the answer from part 1. Sorry, handwriting. R and T. Okay, then multiply negative on both sides, sine 4 theta equal to 0. Remember what happens when the right hand side is a 0, positive 1 or negative 1? What do you have to do to solve? One times sine equals to a 0 or positive 1 or negative 1. What do you do?
What do
Sine
I
inverse?
do?
You sine inverse? No.
Zero.
No. That's only when it's non-zero. You draw the graph.
Oh,
Remember, draw the graph. But lucky for you, this question only restricts to 0 to 90. So you only need to look at this quarter. Sorry, this first quarter of the sine curve. Okay. So that means if you equate to 0, there's only one answer. Okay. This is y equals sine 4 theta. Then that is y equals to 0. This is y equals 0. This is y equals, maybe I should use red pen. This is y equals sine 4 theta. So just find the point of intersection. You realize it's over here. So what's the answer? Oh, did I do something wrongly? Let me double check. Let me see. Right, correct. So there's only one answer, 4 theta equal to 0. Is that okay? Okay. One more small point that I have to bring up is, sorry, actually maybe it's not such a small point. No, it's not such. It's actually a rather big point. I made a mistake with the graph. Can you see what's my mistake?
it should be like 4 times of it.
Yes, correct. Let me redraw this. First copy. Second copy. Third copy. Fourth copy. I can cheat a bit because I have iPad. So this will end up at 2 pi. So you divide by 4, 2 pi over 4. 2 pi is 360 degrees. Divide by 4, that will be pi over 2. So that means it will be multiples of pi over 2 here. This is 2 times pi over 2, which is pi. This is 3 times pi over 2. Then 4 times pi over 2, which is 2 pi. Okay? So let's see again the improved graph. Here, the question asks for angles between 0 and 90 degrees, 0 and pi over 2. So what it means is actually this graph, okay? The red color curve, can you see?
Yeah.
Okay, good. Maybe I should use red pen. Red color. Okay, wrong shade of red. Let me try and be more accurate. Okay, like this. And then you have y equals 0. So it's this guy over here, the x-axis. Where's the intersections? Can you highlight for me where is the intersection? How about the point over here? Cannot. Why? 0 strictly bigger than theta, strictly smaller than pi over 2. So actually, it's an empty circle here, empty circle here. So can you draw for me again? Where is the point of this? Exactly, there's only one. So it's actually this point. Okay. Sorry, answer not so simple, not 4 theta equals 0. Instead, it's, let's see, what do you think it is? The point that's in the middle of 0 and pi over 2.
Pi over 4.
Yeah, pi over 4. But would this be theta or 4 theta? It has to be theta. Okay, because we're drawing the x-axis here is theta. And y. Only when it's theta, then we have sine of 4 theta, then we need to draw 4 copies of the same curve from 0 to 2 pi. Okay, so anyways, theta equals pi over 4. Can I accept?
Yes.
Okay. Very good. Moving on. So what else did they ask for? Find the exact value of theta. Yeah, that's it. Theta equals pi over 4. Good. Can. Moving on. Any questions? Any questions?
Nope.
Nope. Okay. Cause max admit. I'll send you the file later, don't worry. If you cannot copy in time. Okay, so question 7. Let's see what happened. Question 7. Okay, yeah, I misread the question. Sorry, this one wrong. Delete. I misread the question. Let's see the question again. So we start off with a circle. I thought C is the circle itself.
Yeah, same.
It's actually referring to the center. They didn't label the circle. So you have a circle and then there's a point C, center C. And they gave you the equation of the circle, but they didn't label it. Maybe I'll just call it 1. Okay, equation 1 is circle. The point in the middle, the center, is called the C. Point C. And P and K are constants. C lies on the line, blah, blah, blah. Okay, so C is not the circle, it is a point. So in this case, if I do a quick check, bring the 2y over, I get 3x minus 8 equals to 2y. Divide by 2, I end up with 3 over 2x minus 8 over 2, which is 4. Positive 3 over 2x, y equals, means that I have positive gradient. So that means my graph will look something like this, right, for my straight line. Okay, and yes, the point there was 2 comma negative 1. I think you found that out already from the other worksheet you submitted. Where did it go? Let me see. Was it this one? Okay, no, I need to go and download it. Sorry. Where is it? There's another 7 to 11, right? Sorry, give me a second to download it. Oh yeah, by the way, could you go download the other paper I sent? Have I sent it already? Anderson statement. Yeah. Yeah, if I think I have extra time after this, I can go and go through that worksheet. Okay, so let me, okay, I'm back. Can you see my chat screen?
Yeah.
Cannot? Okay, good. So, yes, the correct procedure, what you're doing is perfectly fine. You complete the square. Okay, what you did was to add half the coefficient of x, like p over 2 square on both sides, and then add half the coefficient of y, p over 4 plus 2, right? Because you divide by 2, 4 becomes a 2, 2 becomes a over 2 becomes over 4. And then you square it and you add up to both sides. That's perfectly fine. Then you complete the square and you get this point. You also have this equation of the straight line. It passes through the center, x comma y. So you just have to sub in the x, sub in the y, and solve for p. You eventually show that p equals -4, sub back into an x and y coordinate, you get 2 comma -1. Very, very good. Very, very good. Okay, now is the hard part. Okay, let's take a look. Let me record down on sheet. This is 2 comma -1. The equation is x minus 2 bracket square plus y minus -1, which is plus 1 square, equals to some ratio. In this case, your working was already correct. Let me double check again. Let me copy your answer. 5 minus k. Okay, good. Where is it? 5 minus k. P equals -4. Center is 2 -1. The radius is, you told me already, square root of 5 minus k. Right? Correct so far? Good. Okay. So using this information, part 3, you want to find the value of k given that x equals -8 is a tangent to the circle. Okay, so the key thing here you need to remember is you must really go and practice how to draw a sketch of the equation of a circle. Okay. So if here is 2 comma -1, that means where's my x and y axis? Imagine x here, y here. 2 comma -1. Start from origin. 1, 2. The -1, 1 step down. So somewhere here. Right? Okay, let me erase the arrows. Very messy. Let me erase the point. Let me just make it a cross like this. Can accept this diagram so far?
Okay.
Good. So now we're going to draw a circle. Let's draw a bunch of circles. Let's say that the radius is very small. Can you tell me what's this vertical length here? What's this length? This is
This
2
like
comma -.
it would be 1.
It'll be 1, right? Okay, so what happens if I have a radius 1 circle? It has to look something like this, right?
Yeah, then it would just be touching.
It will just be touching the x-axis. But where's x equals -8? How does x equals -8 look like?
So it would have to be like,
Draw for me x equals -8. Yes, exactly. You have to make it bigger. Okay. So let's just pretend that x equals -8 is somewhere over, I don't know, somewhere here, huh? Completely inaccurate, but okay, you get the idea. Then what you need to do now is to draw a bigger circle. So just draw a bigger circle. Let's say now it's, I don't know, some bigger radius. Okay, let's say it touches only one point at the y-axis. So what do you think is the radius of the circle right now? With respect to the center.
2.
Yes.
2.
2, right? It has to be 2 because it's 2 comma -1. Okay, maybe I'll just label this radius.
So they touch -8, then the radius is 10.
Very good. Yes. So let me just quickly draw a sketch of the circle. You get it already? Okay, not very inaccurate.
5 minus k equal 10.
Yeah, so over here from -8 all the way to 2, the distance is 10. So therefore radius must be, maybe I should use purple instead, equals to 10. Then from there you solve for k. Yes, correct. 5 minus k equals to 10 square, 100. Then k equals
Equal -95.
Yes. Yes. Very, very good. Okay. Ken, next one. Let's go. The coordinates of point A is 14, -8. Show that A lies outside of the circle. I'm just going to borrow the diagram that I've drawn previously. Maybe I'll just, yeah, so let me see. Yeah, so can we assume that k is still -8? Yes, I think we can. Yes, yes. So I'll just erase the other diagrams. Maybe my x-axis, I'll make it a bit longer like this. Okay. What are we trying to do? We want to plot a point 14, -8. So here, notice that my diagram is very, very not drawn to scale. Because my -8 is not far enough. Right? You know what? Let's just make it a little bit more accurate. Let's try and make it accurate. If not, the diagram is going to be very confusing. If this is 2, I need to have 8. So it's maybe something like this. A huge circle. Like this. Okay, maybe I'll shrink it down a bit. Can you see? Okay, good. Extend the x-axis like this. Can? Convinced? Good. So let's move on. So the coordinates of point A is 14, -8. Where is 14, -8 then? Let's plot 4 special points. Oh, you got it already?
Wait, wouldn't it be like around here or something?
Let me think about it. Let's see. Let's plot 4 special points.
Okay.
Top, bottom, left, and right. The left is actually somewhere slightly below. This must be radius 10, right? So 10 plus 2.
12. 12
12.
minus 1.
How about the left point? Still a -1, but
But a negative 8.
okay, good. How about the top point?
Y would be -1 plus 10, so 9. 2, 9.
2, 9, good. Next one.
Negative 11 for Y, and then for X is just 2.
Okay, very good. So now we have to plot our 14, -8 with respect to these 4 points. So 14, here is 12 already. So 14 would be, oops, sorry, my highlighter is not showing. Here is 12 already. So 14, will it be to the left or to the right?
The right.
To the right, so somewhere in this region. Then -8. Here is level -1, basement 1. Here is basement 11. Where is my -8? Somewhere over here. Yes. Good. Like this. Okay. Always use those 4 points as a reference.
Then how to show?
Show. Okay, so the key idea here is always compare with the radius of the circle. Imagine radius is a fixed distance 10, right? Sorry, yeah, radius is a fixed distance 10. 10. 10. This distance 10. All 10. Agree? Then this point to this point, if you are smaller than 10, will you be inside the circle or on the circumference or outside the circle? Let's say this is 9.
You'll be inside.
Inside, right? If it's 8, still inside.
Oh,
has to
like
be
that.
somewhere
So
even
you
closer.
do from the center, distance from center.
From here until this point. Measure the distance. You know the distance formula, right? Yes. 2, -1 versus 14, -8.
Wait, I realized.
Undo. Your Y coordinate. Yes,
Wait.
much better. -8 minus -1 and +1. Carry on. One four four plus 49. I need to use a calculator, I guess. Okay, I mean, 193 is bigger than 100, so square root 100 is 10. So that means it must be bigger than 10.
It's more. So it's bigger than 10. Therefore, it lies outside the circle.
If you don't want a calculator, you can compare it with square root 100. Right? 193 bigger than 100, you take a square root, the inequality direction stays the same. but square root 100 is actually equals to 10. So that means square root 193 is bigger than 10.
Okay.
So outside.
Why can't I just like do something like I sub in like 14 into the equation of circle. Then I'll get like some different x or something.
You will get a quadratic in terms of y, and you cannot solve. Yeah. Then cannot solve can mean two things. You are not okay. Cannot solve means you are not a point on the circumference of the circle. But you could be inside and could be outside.
Right?
No,
do
you want to try? Okay, maybe just...
No, I don't want to try. I don't want to try.
Okay, you just get a quadratic.
I know what you're saying.
Yeah, good.
I believe.
Actually, over here from this diagram, it's super obvious that it's outside, right? You just compare this point, it's already outside.
Why can't I do the diagram? Why must?
So the why I drew this diagram is to convince you that it's outside. You don't need to draw the diagram. You just need to remember this trick.
Do it. And then there's like, we cannot just draw it. Then like, oh, sure.
Okay. I mean, you could, but usual trick here is we teach the students for speed in doing exam is calculate the distance to the origin. If you are smaller than the radius, you're inside. If you're equal to the radius, you're on the circumference. If you're more than the radius, you're outside. As simple as that. Okay? I mean, it's just a few lines. I think it's faster. Could you draw a diagram? I mean, yes, I guess so. Yes. Quite convincing. But you need to make sure the diagram is accurate, which may be a bit challenging in exam conditions. Right? Okay. Okay, I'll send you the file later. I'm gonna move on already. Can? Need to move on. Sorry, moving on. Okay, part V. Point X. Okay, I'll show for a few more seconds. Point X, it lies on the circle such that it is furthest from point A. What's point A again? Oh, point A, I forgot to label A. State the geometrical relationship between points A, C, and X. C is the center, not the circle. So, question. What is the longest distance between 2 points on the circumference of a circle? Sorry, badly phrased question. Let's say you start off with a circle, you pick 1 point, and then you want to, this is a fixed point, I'll call it F, and then I want to pick another point G, somewhere along the circumference of the circle. G candidate 1, G candidate 2, G candidate 3, G candidate 4, G candidate 5. Okay, which option, which G would you want such that FG something, FG question mark, which option, 1, 2, 3, or 3, 4, or 5 will have the longest distance? Is it FG1 or is it FG2 or anything else?
Not, it's definitely not.
So which option, FG?
If I had to choose?
Yes, just eyeball it.
Oh, then this one.
G3, yeah. So let's see what is so special about this point. It looks like a Pokeball. Okay, maybe I rotate it around. Pokeball. Pokeball. What is this line called? If it passes through the center of the circle?
Diameter.
Yes, that's a key idea. This is center, C, C for center. This is called diameter. The diameter will always be the longest distance. If you have a fixed point and then you want to pick another random point, G1, G2, G3, along the circumference of the circle. Okay, you want a diameter, and the diameter always passes through what? Always passes through the
center.
Pass through center. Okay, so pass through the center. So same idea, same thing over here. You have a point A. Sorry, let me highlight it to be more obvious. You have a point A here and a point C there. Then they tell you you want a point X. So where do you think a point X will be, the candidate? Would you want a point X here? Cannot be lah. How to draw a straight line like this? XCA. Cannot be. Oh, sorry. I revealed the answer. Oops. Pretend you didn't hear the straight line part. Point X lies on the circle such that it is further from A. So do you think you want an X here? X candidate 1? Or do you want an X here? X candidate 2? Did you interpret this? Did you understand what this question was saying the first time?
No.
No, okay, but now do you understand what they're asking you to do? Consider all these possible options for x. x1, x2, x3, all the way to x8. Which one do you think is the furthest away? x4.5.
X. Whichever one
is the furthest away from the point A.
make
Would you want x7 or x8? Cannot be right, too close already.
So you're telling it passes through the diameter. I mean, it passes through the C.
Yes. So
what the hell? Okay.
I boy, which point do you think it could be?
4.
x4, huh? Okay, so let's just draw that point. X. Let's just call this X. Then you draw a line that cuts across it. And actually, what you said first, pass through diameter also not also accurate. You see, diameter is over here. You see? The green highlight diameter. It passes through the diameter as well, this line. But more importantly, it passes through the center. Okay, so what is the relationship between these 3 points? They lie on the same straight line. That's it. That's all. Is it clear? All 3 points lie on the same straight line. Do you know an adjective to describe this? The points are begins with letter C. CO.
Same line.
Say all 3 points lie on the same straight line. There's a more concise word to describe this. Co from vectors. Emax. Collinear.
Collier, something else.
A straight line is what? Not quadratic, but
collinear.
Collinear. Very good. Is that double L? I can't remember. Sorry. Is it double L? I think it's single L. Collinear. Collinear. Linear means they are a straight. It's a straight line. C and A is linear. X and C is linear. So all 3 are linear at the same time. They are collinear. At the same time. Cooperate. Work with other people. Cooperate. All 3 work together to be on the same straight line. So collinear. Okay. It's just an English class. Okay, that's all. Any questions about this?
No.
Okay, very good. Next, this one. No attempt. What happened? Yeah, this one. You have x power a times y equals to c. And then you have a points x comma y, x comma y, x comma y, next one, next one, next one, next one, next one. Explain how a straight line graph may be drawn to represent the given formula. What happens when you have a multiplication over here? Linear law. Remember?
Big Y.
But before that, you have to make the product turn into a sum plus. How?
Minus C.
Minus C, not so good. Is there another way? We want to chop it down. You want to chop down this. You chop down a tree, you get what? This is a huge tree. You want to chop it down. After you chop it, what do you get? Paper. Before paper.
The trunk. What do you get?
Trunk. The trunk. The log.
Oh.
Log.
So you want to log both sides.
Yes, remember this topic? LG base 10 or LG which is base 10 or LN which is base E. Remember? That's an A, not 9, by the way.
Yeah.
So let's just pick one. Pick either LG or LN because that's the only option available on the calculator. Options. Pick one. LN, sure. So LN left hand side equals LN right hand side. Maybe I color code this. I'll use black. That's not black, that's gray. Where's my black? Over there. Where is my black? Over here. Okay, can. Then what do you do when you have a product? Something times something, you take a log. Or ln. Or basic. Product becomes a plus sign. Ln of AB equals to ln A plus ln B. It's just that the capital A is now a, oops, sorry, don't put equal sign there, equal in the middle. Ln x power A plus ln Y equals to ln C. So what is the ln of C? It's just a constant. Just a constant. Later we'll find out. How about this part here? X power A, more important. What happens when you have a logarithm of x power A?
Bring down the A.
Bring down the A power rule of logarithm. Do you need to bring down the O power then minus 1 to get the new A ln x power A minus 1?
No.
Then ln becomes 1 over, is it? 1 over. Just 2, because you use chain rule, is it? No, these are not differentiation topic. Don't be confused. Some students will get confused. I hope you are not confused. Just bring down the power. Can? Good. Okay, carry on. So, yes, you were saying at the beginning, big X and big Y. Now, after you take the logarithm, can you see who's your big X and who is big Y? Let big X equals big Y equals. What's a good choice?
Don't you have to like
Move things around? Can also, can also. We can modify it a bit more before you carry on with the substitution.
bring down L minus L and Y?
Where? To the right hand side.
Yeah.
Okay. Remember, we need y equals mx plus c. Variable equals to constant coefficient multiplied by a variable plus a constant. That's the format we need. So here, little x and little y, they are our, which one? Variable or constant?
Variable.
Variable. So if you take logarithm of x and y, does it suddenly become a constant? No lah.
No.
Still variable.
Still
Still variable. Okay. So now that you know ln x and ln y are variables, how about ln c? How about ln c?
Constant.
Constant, because c is a constant. You take logarithm of constant, still a constant. So over here, can you see how you can rewrite it in this format? Variable equals constant times variable plus constant.
Okay. A L N. Wait, no. Okay, ln Y. Okay, that's a variable. And then equals to negative A ln X plus ln C. Negative A being constant and ln C being constant.
Very good. Exactly. You got it already. That's it. Let me just copy the label. So there, ln y is a variable. And here, negative a is a constant. And there, ln x is a variable. And here, ln c is a constant. Can see the pattern now? Very good. So what clever substitution would you want to do now?
Let y equal ln y.
Yes, exactly. That's it.
Let x equal x.
That's it. Then finally you get y equals to negative ax plus. Okay, if you want, you can introduce a capital C to replace ln c, but I don't think there's a point to doing that. Just keep it as ln c. Okay? Very good. So explain how a straight line graph may be drawn. Okay, so the explanation is you can get this format and then you can just yeah, that's it. I think this is good enough. This is the equation, the equation of a straight line. That's it. That's it. Is that okay? Yeah, you just have to draw a table of ln x and ln y values. Okay, previously they gave you X and Y. Now you have to upgrade into a table of lnx and lny values. Okay, really need to throw into the calculator and type in. Okay, so let's see part 2. On the grid above, draw the straight line graph for the given data and show that 5 of the readings are a close fit to the formula. Okay, let's just follow the procedure. So over here we have capital Y equals to negative A times capital X plus ln C. So capital X is ln X, capital Y is ln Y. That means we need to plot points where the x-axis is now capital X, and y-axis is now capital Y, which is ln Y, which is ln X, respectively.
So I have to type in calculator.
Correct, yes. All the x must type in ln, pick a ln. So help me to calculate what is ln of 1.2. Okay, maybe you know what? I will calculate ln X. Can you help me with ln Y?
Yeah.
Show the calculator. Just 5SF will do. Maybe 2, 6. Just copy the first 5 non-zero decimals, non-zero digits. Zeros. Next one. I'm not even rounding off. 0.693147. I just stop at 4. 1, 2, 3, 4, 5. Fifth non-zero digit, and I just stop. This is called truncating, a lazy way. Don't need to round up or down. Truncate to 5SF. 9, 5, 5, 5, 1. Is that all? No, there's a bit more. Oh, sorry. Let me just quickly calculate this. 1, 2, 3, 4. Still got 3.5 and 4.5. Give me a second. 3.5. I get 1.25. Let me see. 27. And then ln of 4.5. ln 4.5. What do I get? 1.504. 0. What's the answer? Let me see. I cannot see. Hold on, don't erase yet. What is it? I'm gonna copy this down. Two, 3, 5, 7, is it? 572. Okay, can. Good enough. Now I have this table. We have to realize that this is capital X and that is capital Y. We have to start plotting capital X, comma, capital Y in our graph. Let's go. So, what's a good scale here? Let's see. The capital X goes from around 0 all the way to 1.5 out of it. So let's say 1.6. So 0 to 1.6. What would be a good scale? Let me look at the graph carefully first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here, 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 and here. How many spaces do I have? 10, 20. Oh, no,
6.
Maybe I counted wrong.
Wait. 1, 2, 3, 4, 5, 6, 7, 8. 8.
8. I need 1.6. So 1.6 divided by 8, 0.2 each. So 0, 0.2, 0.4, so on. You get the pattern. 1.2, 1.4, and 1.6. Good. Then how about the Y? It goes from, what is it? Negative all the way, negative 0.2 to 2.4. So the range is around, let's say negative 0.1 up to 2.5. Right, so that's around 2.6. It's around 2.6, right? Okay, good. So let's see how much space we have. 10, 20, 30, 40, 50, 60, 70, and 80. Or sort of 80 tiny boxes. You need 2.6. So if I put around 0.2, 2, 4, 6, 8, 10, 12, 14, 16, not enough. 0.2 is not good enough. How about 0.4? 4. Maybe 0.4 is okay. 0.4 is okay. 0.4, 0.6. Sorry, not 0.6. 0.8, 1.2, 1.6, 2.0, 2.4, 2.8. Is that all right? No. Why? Because we need a negative 0.1. So we need to shift everything up. One position, 0.0, 0.4 negative. Can? Then from there, this one has to go upwards.
Oh
right?
my gosh. Yeah, okay.
Okay, with the iPad, I have the advantage of just selecting and dragging it, but if this was paper and pen, you have to erase and draw, erase and draw. Oh. So just be careful. Hey, I actually drew the axis, the y-axis for us, so good. I don't need to draw one extra line. Save some pen ink. Okay, good. Then now we just plot points. So let's see. 0.18232. Let's just approximate. 0.1 is here. Each tiny box will be worth how much? Let me calculate this. 0.2 divided by 10, so it's around 0.02. If I point 1 or 1.8, 0.1 plus 0.08. 0.08 is how many 0.02s? 4 of them, right? So that means it must be somewhere between the 4th box or the 5th box after 0.1 here. So it must be somewhere in the middle over here, right? That's x equals 0.18232. Here is 0.18, there is 0.20. So 182 is somewhere in the middle. Just assume that it will be directly in the middle. Even though 182 is like slightly smaller than 185, which means it's a bit more to the left, but we don't have that kind of precision in drawing a graph. The highest precision is half of our tiniest box. Are we clear on that? Okay, very good. So just plot in the middle. Plot over here. So that is my 0.182. But x equals 0.182 is not enough. We need a y equals, capital Y equals 2.406. Oh, sorry, I made a mistake over here. Not curvy little x, it's capital X equals ln x. Likewise on the numerator, forgot to label y equals ln y. And yeah, for the origin, just label one time. A single origin will do. Let's see. So where is 2.4? 2.406. This particular value here, 2.406. Let's see. 2.4. And to draw take a ruler and move it upwards like this. Okay, roughly. Then 2.406. Let's see. Here the distance is 0.4 for 10 tiny boxes, so it's 0.04 for each tiny box. You have a 2.4 is over here. The next tiny box will be 2.44. 2.406. Definitely closer to 2.4, but let's just take it to be in the middle. Okay. So the point you should plot will be somewhere here. The intersection. Like this. Can you see? Okay, so let's just plot a point there, like this. Okay, good. Next. Move on now. 0.47. Okay, let's see. Each tiny box is 0.02. So 42, 44, 46, 48. 47 is somewhere in the middle. So it's 3.5 tiny boxes after 0.4. Just extend my ruler up all the way. If you are doing this in paper and pen, on paper and pen, take a ruler up all the way. And then you plot the y coordinate now. 1.83896. 1.83, maybe. Okay, I think a more efficient way is to just take a screenshot. then I don't need to keep on scrolling up and down. Okay, like this. So where is my 1.83896? Let's see. 1.6 is here, 2.0 is here, each tiny box is 0.04. So it's 1.6, 1.64, 1.68, blah, 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 blah. Okay, maybe it's better to start from 2. 0.04 to 1.8, that's around 0.20. 0.20 divided by 0.04. 20 over 4, that's 5. So it's somewhere 5 boxes down. Over here, which is a 1.8, right? 1.8. So the next box is 1.84. I need 1.83896. So it must be in between 1.8 and 1.4. So it must be over here. Can you see? Can you understand this?
Yeah.
Can Okay, good. Next one, let's go. So we are gonna plot 0.6931. So 0.6 is here. 0.7 is over here. So where is my 0.69314? It has to be, each tiny point is 0.02. So this is 0.68, right? This is 70. How do you get your 69? It must be somewhere in between. Okay, somewhere in between, like this. So we just extend upwards, like this, and then we try to plot the y coordinate now. So 1.3812. Where's 1.3? 1.2 is here, 1.6 is here, 1.4 is in the middle. So 1.3 must be somewhere in the middle here. Let's see. This one is 1.24, 1.28, 1.32. Where's my point? 1.38. So continue. 1.3 plus 0.04 is 1.36. And the next one will be 1.40 over there. So 1.38 must be between 36 and 40, right? So my 1.36 is over there. 1.40 is above. Where's my 1.38? It's in the middle. So we're gonna pick the point in the middle. So if I just draw it nicely, take a ruler if you need it. Yeah, I think it's strongly recommended to use a ruler. And then you plot the point over there. Okay? Okay, next point. Oh, just keep on going. Just keep on going. No choice, no choices. Oh, by the way, all these are extra 0.68 and 0.70. Please erase them after you're done. Don't want to confuse the examiner if you're plotting points. Okay, next one. Where were we again? Okay. Here, 0.95. So it must be somewhere 0.9 here. Then each one is 0.2. So 0.92, 0.94, 0.96. What was the point again? 0.95, right? So it's between 95 and 96. About 94 and 96. So over here, right? Let me just move my ruler over, something like this. Okay. Then now I have to plot my my y coordinate, which is over here, 0.85866. 0.8 is over here. Each time I move up, it's 0.04. So that means this point is 0.84. Next point is 0.88. 0. Plus 4. Wow, this one, 92. Okay, might have chosen a not so good scale. That's why it's taking I'm having a slightly more difficult time to calculate this. So this is, what do I want? I want 0.85, right? So 0.85, where is it? 84, 88, 92. I want 85.
Between 84 and 88.
So somewhere over in the middle here. Okay, so do that. We're gonna, okay, wait, let me just draw a horizontal line. Then I'll extend it. Okay, like this. Extend all the way, and then you get the intersection over there, PowerPoint. Okay, so on so forth. You get the idea already?
Yeah.
Okay, good. Then I'll just quickly plot the points. So there's a 0.02 here, 20, 22, 24, 26, so 25 in the middle. And then you need, what is it, 0.43825. 0.43, 0.44448. So 43 must be between 40 and 44. So it's over in the middle here. Extend a bit more until you get a intersection over there. Plot a point. Oops. Just plot nicely in the middle. Okay, done. Next one, we're gonna plot 1.5. Here's 1.4, here's 1.6, 1.5 must be somewhere in the middle. 5 tiny boxes after. So it's somewhere over 1, 2, 3, 4, 5 over here, 1.5. Each tiny box is worth 0.02 here. So the next one will be 1.52. Next one will be 1.54. Here, then here. What do we want? We want 1.50. So it must be 504. So it must be somewhere between 1.5 and 1.52. Right? Okay, so let's just move it over there. Then after that, you have a negative 0.235. Where is negative 0.235? Let's just move this graph down. So negative 0.2 must be 1, 2, 3, 4, 5 boxes here. That's my negative 0.2. I want 235. Okay, each time I go down, it's 0.04. So this will be, the next point will be negative 0.24. Next one will be negative 0.28. So where's my 235? Must be between negative 0.2 and negative 0.4, right? So I'll just move it down halfway. Okay? Good. Then you just extend until you hit the vertical, the y-axis, the vertical line. Okay, good. Then you plot the point there. And then finally we are done. Clean up, erase all the helper lines. Erase. Don't make it so messy. Okay, but the original tick marks must remain, like the 0, 0.4, 0.8, 1.2. All the others must go away. Erase. And erase a bit more. And okay, done. We have our points. What do we do now? Draw the line of best fit. So the idea behind line of best fit is that you want to draw a straight line such that the number of points above the graph and below the graph will be roughly equal. So is this a good approximation?
No.
All right, definitely not. How about this one?
No.
Even worse, opposite direction. I think you can tell it's a diagonal one. How about this one?
No.
Correct direction, but all the points upwards, can? Sorry, maybe I should hide. I should go presentation mode. Okay. Is this line okay?
No.
All the points above. How about this one? All the points below. Cannot, so that means it must be somewhere nicely in the middle. Try your best to make sure the line can pass through as many points as possible. Just try your best. There's no correct answer, no fixed answer to this until you learn regression analysis. Then there will be a perfect answer. Let me just write this down. Regression analysis. There is a mathematical way to find the line of best fit. A perfect line of best fit. By perfect, it's with apostrophe. It's called a regression line. This is a topic that will only be dealt with in A levels. Okay? But for now, you learn the basic stuff. Draw a line of best fit. How many points above, how many points below? Do you think mine's good enough?
Yeah.
Can maybe I can improve it slightly by tilting it a bit more so it cuts through like this. Then I extend a bit more until like this. Maybe I'll make it just a bit. Okay, here. No, do you know the idea between interpolation and extrapolation?
No.
So the idea here is that when you have a pointer, that's the let's say the largest x coordinate, it's over here. But what I did was I extended it a bit more. So what I can do is I can predict for values that are bigger than this x, what's the corresponding y. However, that may not be so accurate. The maximum x value is this one, around 1. X equals 1.504. If you let's say extend all the way to here, then you sub in x equals 1.6 and read off the corresponding y. That's known as extrapolation. Okay. You pick a x, you draw the graph long beyond the given x values. Whereas if you try to pick a value that is smaller than the maximum or larger than the minimum x value, and then you read off its corresponding y coordinate, like for example, in this case, if I sub in x equals 0.4, and then I look at its corresponding y coordinate, this is known as interpolation. Inside. Okay. Using x values that are within the given interval of x values. Smaller than the largest x value, bigger than the smaller x value. Or what I like to call the domain of the interval. Domain of x. Domain of the function. Okay, here what happened? My line of best fit, I exceeded it a bit. So I don't want that. I try to make it exactly the same x coordinate, roughly like this. Can you see? Don't exceed. Likewise on the left side, just try not to exceed. I like to usually out of habit, I like to make it pass through the first point. You don't need to. Just try to make it pass through as many points as possible. So here I think mine looks kind of okay. It passes through 3 points. There's 1 point that's below, 1 point that's above. Okay, another point that's above. I guess that's roughly good enough. That's good enough. Okay, maybe this one. Okay, at this stage, you realize that most of the points are very close except for one particular point. Can you tell which point is a bit far away?
The second last one.
Second last one. So now we can answer the question. On the grid above, draw the straight line graph for the given data and show that 5 of the readings are close fit. So 1, 2, 3, 4, and 5. Okay, maybe the 5th one not so accurate, but close enough.
Well, what do you mean to show?
Just draw the line of best fit and make sure that 5 of the points are very, very close to the straight line.
Oh, okay.
Yeah, these points, they are very close to it. That's all. Okay, good. Think so. Yeah. Moving on. Any questions? So far?
No.
Just plotting points. Okay, Ken. Moving on. So part 3, assuming that x is correct, state which value of y appears to be wrong and estimate where it should be to fit the formula. Part 3. Which value of y appears to be wrong? You already answered me. The one that is a bit further away, this guy. So how do you approximate the correct, with apostrophe, value of y? They said assume that letter x is correct.
You use the same x, like what is it? The same 1.2527.
Yeah, that's a ln x. But that's okay. It's okay. You can go and scroll up to check the letter x value. Sorry?
Can you just like find the big y, then find the like e power whatever thing?
Exactly, yes. But can you tell me what's the corresponding y? How do you get the correct version? Hint, interpolate. The question mentioned that the x coordinate of this point you can assume is correct. Yeah. Wrong already.
Okay, I don't know.
This point has a x comma y, right? Some x, some y, right? Let's just call it x1 and y1. They are telling you x1 is okay, but y1 not okay. Because why is y1 not okay? Because it is too high up above.
Wait.
So you recycle the same x. Yes, that's the correct way. Hit the graph, then you want to read off the graph. Yes, that's how you do it. That's my x1 value, sub in, and then get the corresponding y. So with my iPad, I can do it a little bit more accurately. Let me use purple color broken line to show you. Okay, so like this, I can drag it. Oh, my x-axis. make it a bit more accurate. And it intersects the graph. Can you see the purple line? It's a bit, it's broken purple line like this. Okay, maybe I should increase the font size to make it a little bit clearer. Close enough. Okay. Anyways, so now we get the corresponding y coordinate, which is this guy. So what is this value here? Let's see. 1, 2, 3, 4, 5, 6. 6 tiny boxes. 6 tiny boxes. One tiny box is worth how much? Here's my calculation over there. There are 10 tiny boxes in an interval of 0.4. So divide by 10, I get 0.04 as the length of each tiny box.
0.24.
Here it's 6. So okay, 6 times 0.04 is 0.24. So it's above the 0, so that means that point must be 0.24. Did I calculate wrongly? I hope not. 24, 28, 32, 36, then 40. Yeah, should be correct. Okay, so therefore, what do we conclude? Is it little y equals to 0.24 or is it big y equals? Okay, very good. Big Y. So go back.
E power 0.024.
From the graph, a big Y, so ln Y equals to 0.24, and therefore Y should be e power 0.24. Yeah, blah, 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 round off 3SF. I am sure you can do this. I don't want to do it. Okay, moving on. Let's see. Find the value of A and of C. So
take one of the points from the graph.
Okay.
Then you sub in e power whatever the value is for both of them.
E power is later because when you read off the graph, it is capital X and capital Y. And what is the formula we have here? Capital Y equals negative AX, capital X plus ln C. Okay.
Oh. Wait, like that you can't just
one
use
point is not enough.
Yeah, use 2 points then simultaneous.
Yes, very good. Here I'm gonna be lazy because wow, look at my line. Just nice, it passes through this point and this point exactly. So I'm just gonna recycle these 2 points. Okay. The first and fourth point. So first and fourth point. Let me just copy those points. This one and this one. Okay. Okay. Good. Okay. So copy this down. Let me copy the equation as well so I can save a little bit of time. Okay, so we're gonna sub in, let's say the first point 0.18232. Actually, you know what? Let's just rewrite it as ln y and ln x. Why? Because I know the exact value of the x and the y here, the corresponding x and y. Right? I know the exact value. It's the first and the fourth one. So I'll just copy the data from the question. The first and the fourth one is this one and this one. Let me just take a screenshot so I can not scroll up and down. So it's over here, right? So we can just sub x equals to 1.2, comma y equals 11.1. So normally you can't do this. Normally you would say you would sub capital X equals to whatever was the point you've managed to find, 0.18232, and capital Y equals to 2.406945. Do you know what I'm talking about? Where these values come from? It's from here. The first point. It just so happens that it is a point that I plotted, and the graph also passes through. Just a coincidence. I could have picked any other point and sub in the capital X and the capital Y. Okay. You know what? Maybe I should just show you the generic method. Don't give you the special case with the little x and little y. That's a bit confusing. I'll show you the generic method, the capital X and capital Y. Pick a point on the graph that the line passes through, sub in capital X, sub in capital Y. So let's do that. 2.40695 equals to negative a times 0.18232 plus ln c. Okay, that's equation 1. Then after that, you go on to sub the next point. Let's see, what is it? 0.95. How many fives are there? 3 of them. 1, capital Y equals, what's the other guy? 0.85, 866. And then I obtain, oops, 0.85866. Oh, iPad, please behave. 0.85866 equals minus a times 0.95551 plus ln c, equation 2. So from, let's say, 1, I can make, I don't know, ln c the subject. So ln c will be equals to, just to save some time, 2.40695, then minus bring over become a plus a times 0.18232. With this equation, I'll call it 3. I'll sub 3 into 2. So notice that I didn't make C the subject. I made ln C the subject because it's convenient. Okay? So therefore, I'll get this plus ln C, which is equation 3. Are you following so far? Mic test.
Yeah.
Can hear? Okay, very good. You see what's going on now? The ln C replaced with whatever was equation 3. Equation 3 came from 1. Sorry, bad handwriting. Let me rewrite it. FROM. All right, good. Then from there you can solve for A. Let's see. There's a minus 0.95551 plus a 0.18232. Let me show the calculator so it's a bit more convincing. Shrink it down, bring out the calculator. Where's my calculator? Yeah. Oops. Nope. Go away. Go away. I want my calculator. Okay, good. So coefficient of A, negative 0.95551 plus 0.18232. Add together, I get negative 0.77319A. And the constant over there, bring it over. So it's 0. Equals. So it's 0.85866. Subtract away 2.40695, which gives me, let's see, negative 1.54. Oops, negative 1.54829, and then finally A equals to negative 1.54829 divided by negative 0.77319. Is that okay? Following so far? Okay, then you divide by, good that you're following, 77319, and then you get 2.00247. 3SF, that's around 2.00. Okay? Very good. So that's A. Then after that, if you want to solve for C, can I leave this as an exercise for you?
Okay.
Into, let's say, equation 1. From there, blah, 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 solve for ln C, and then after that, solve for C. Okay? Oops, is it blocking? Can you see the working?
Yeah, I can see it.
Can see it working. Okay, very good. Let me hide the calculator. Okay, good. That is one way to solve A and C. Plot 2 points. But is there another way? Yes, there is. Yes, there is. So what's the other way? Let's take a look at this equation again. Y equals mx plus c. What is negative A? It's really just m, right? Which is the gray what? Gradient. Slope. How about ln c? What about ln c? What's this?
Constant.
No. In terms of a y equal mx plus c,
Y-intercept.
is the y-intercept, the geometric interpretation. Okay, very good. So can we find the gradient and the y-intercept? How do we find it? Let's say the gradient. Graph question, how to find gradient? For point x1, y1. What do you do next?
Sub.
No. How do you find gradient? You need another point, right?
Yeah.
X2, y2.
X1 minus.
Rise over run.
Hmm.
So rise divide by run, which is really just the formula you're saying. Y1 minus y2 over x1 minus x2. Calculate, and then you get your answer. That's your negative a. So this will be equals to negative a. Then from there, a equals to negative of . You understand the procedure? Do you need me to show an example?
No.
No? Okay, good. Then how about y-intercept? At this stage, there are two cases. Usually what you do is this as your step one. Okay? Find the m. In this case, m is equals to negative a. Then from there, you have to solve for a. Okay? Times a negative 1 over. Then your step two, there are two approaches. Method number one. Sub the m and the x and the y. Because you have already, sorry, actually I shouldn't say this. This is actually usually not little x, little y, little x, little y. It's capital X1, capital Y1, capital X2, capital Y2. Okay? Right? Because it's no longer a little x-axis. No, it's capital X. In this case, equals ln x. It's no longer little y. It is ln of y, which is capital Y. Right? Remember the axis change? Big X and big Y. Yeah. So over here, when you use gradient formula, your plot, your point is actually capital X, capital Y. So over here, you also need to substitute in X and Y. This actually refers to a pair of coordinates that is a point on the line. Okay. So what you see is that if you sub in m, x, and a y, the m being negative a, x, and a y, what's the only unknown that's left in this equation? Which one I haven't taken yet? Sub in the x, sub in the y, sub in the minus a. What's the only thing left? That's not ticked. Mike Tess, are you following?
Yeah.
Who is the only guy that's not ticked in the equation? Yes, ln C. So that means that you can solve ln C, solve for ln C. And then from there, you can solve for C. Do you understand what I am saying? Procedure. After you have, tell me if you don't understand it. Do you need me to show you an example?
No.
Don't need, Okay. Can, then you sub in the m. Okay, sub in the m. Then calculate. You will be able to substitute this whole expression here. Sub in the x and sub in the y. All three sub in already. You're left with ln C. Make ln C the subject. Then you e power to make C the subject. That's how you solve for the C. That's method number one. What's method number two? Method number two is a bit lazier. It's independent of step one. What do I mean by independent? It means you can do step two, method two first as your step one, and then step one as your step two. Interchangeable. This one just requires you to do the following. Extend the graph. Extend the line until it hits the y-axis. Sorry, not little y, capital Y-axis. Right? Then from there, you can just read off the y coordinate, and that's your ln C. Does that make sense? Right, so maybe looks very messy. Let me just bring it up. Oh. So this one I can show you quickly. So what I mean is you just have to extend this all the way, but make sure that your y-axis is long enough until you get a Then you just have to read out the y-intercept. Then from there, capital Y equals to something equals to ln little y. From there, to make little y the subject, the ln must be brought over. So you end up with e to the power of something. Okay, that's another way to solve for. That's another way to solve for a C. Okay, can yeah.
Okay.
Usually you won't use this method because the y-axis is too short. You cannot hit the y-intercept so easily. All right. You get the ln C, sorry, not ln y. You get ln C. Then from there you can solve for C. Okay. I will leave you to try on your own. That's it. Can how about the rest of the questions? Let's continue. Oh, maybe not enough. Talk too much. Let's see. Question 9 part 1 was fine. 9 part 2 not okay. Okay, let's see. What's 9 part 2? 9 part 2. This one. Show that this weird sum here is less than 5 over 6. What do you think?
It's one of those where you like break up, but then I don't know how you do it.
Yeah, you have to break it up into rectangles. So let's take a look. Do you notice that this is really just 1 over x squared, but you sub in x equal to 2 the first term? Then this guy 1 over 3 squared is really just 1 over x squared, but you sub in x equal to 3.
Oh.
Likewise for the other guy, 1 over x squared. Oops, square is on the top right. Sub in x equals to 4, so on and so forth. So let's take a look at this graph. You have 1 until 6. Here, it only goes from 2, 3, 4, 5, then 6. So what do you think you want to do? Yes, you got it. Chop it up into a bunch of rectangles. Oh, maybe, sorry, pause a while. Let me zoom in first. Easier. Remember the goal was 1 over 2 square, 1 over 3 square, plus 1 over 4 square until 6 square. So. Hey, your 3 a bit off.
It's all off. Oh my gosh. Oh my gosh. I hate this. Yeah, okay.
Let me just adjust it a bit for you. Maybe something like this. Looks good enough.
So it's just the part where it says less than. It's just the area from 2 to 6.
That's the exact area. What are you shading?
Oh no, nothing.
Let's represent this geometrically.
Okay.
How do you do that? What is the function here? Y equals 1 over x squared, right?
Yeah.
So if x over here is equals to 2, what's the corresponding point over there? Must be 2 comma 1 over 2 squared. Sub in the x with y. Sub in the x with 2. Right?
Okay.
So what's the height over here?
Oh, 1 over 4.
Or just leave it in the format 1 over 2 squared. Of course, I know it's 4. Sec 1 kid also knows it's 4. That's not the main point. The main point is to recognize the pattern here, which is required by the question. It's the same as 1 over 2 squared, which is also the same as 1 over 2 squared times 1. How about 1 over 3 squared? Where can you find a 1 over 3 squared? And this is also times 1. 1 over 4 squared also has an invisible times 1. Times 1. Oops. Sorry, a bit off. Let me adjust it. Give me a second. This is bad. How do I get it back? Okay, good enough. Something like that. Yes, very good. Very, very good. Wow. Right. So this is the staircase shape, right? The staircase shape. Did I? Okay. 5, 6. So the area of the first rectangle, that's corresponding to 1 times 1 over 2 square. Why? Because the length here, the breadth here is 1, or length, breadth doesn't really matter. Let's say length here is 1, the height here is 1 over 2 square. Then you get the area of this first rectangle. Maybe to make things clearer, I'll call this A1. Then I'll call this A2, A3, A4, and A5. Can see? Maybe it's easier since I have highlighter to highlight it. So yellow rectangle, a blue rectangle, a green rectangle, a purple rectangle, and then a light blue rectangle. Clearly, the sum of the area of these rectangles is always less than the area of this entire shape under the curve, right? This entire region, right? That's the main point. That's all they're asking you to do. Maybe it would be nice if you just label like this A1, A2 until A5, and then tell them that sum of the area of these rectangles is strictly less than exact area under the curve. Areas of rectangle A1, A2, A3, A4, and A5 is strictly less than the exact area under y equals 1 over x squared from x equals to 1 to x equals to 6. Okay, this is basically the application of that Desmos. This is a test of your understanding of the Desmos question that I was, sorry, not question, the Desmos demonstration I showed you before. Okay. Yeah. And yeah, that's it to the question. Oh, interpret the area of each of these pieces, the yellow part, the blue part, the green part, the purple part, and then finally the light blue part to be strictly less than the exact area, which is really just integrating integrating the function 1 over x squared from 1 to 6. Okay. Very good. Then you just have to continue the rest. The answer is 5 over 6 when you integrate to find the exact area. I'll send you the file later, don't worry. Okay, moving on. Let's see. Question 7, what we have. Okay. This is good. This is good. Part 2. Oh, part 2 is good. Part 3 is almost there. What are you doing over here? You multiply by root 12, right? What is it? There's sorry. You copy down. Root 12 cos x minus 60 equals to a -1. Right?
Okay, I don't know what I was doing. I just know it's wrong.
Let's see. You're almost there. The minimum value, right? Okay.
Yeah,
so
how do you find minimum value?
You got it into r cos x minus alpha format already, right? Is it minus? Okay, now your answer was fine. Root 12 cos x minus 60. Okay. Try to use radians. Follow the question. Okay. So what you need to remember is that cosine of x minus whatever, x plus whatever, will always remain in between two values. What is it?
+1, -1.
Y equal 1, y equal -1. So that means that the minimum value, let's say min of this guy, will just be root 12 multiplied by the smallest value of cosine. Root 12 is a constant, so you can't change it, leave it alone. But cosine is can be manipulated. Can be sometimes very big, positive one, sometimes very small, negative one. So what do you think is the smallest value? Must be negative one. So it's negative root 12. That's it. Can?
Oh, okay.
The smallest value that this one can be is negative one, right? X is a variable, so you gotta pick you don't need to know what's the X value, you just need to know the end result. This guy can become negative one. Okay, challenge. What if they ask you for maximum value instead?
Then it's just root 12.
Root 12 times positive one. Huh? Yeah. Huh? Why you need to solve?
Wait, I thought they want corresponding value of X.
Oh, right. Sorry. My fault. Yes, you're right. Yes, they need to solve. You need to solve for X. I didn't read the question properly. State minimum and find corresponding X.
Cosine inverse negative 1.
No.
Wait, why?
Whenever the right hand side is a 1, a 0, or negative 1, I always want you to draw.
Oh, yeah.
Ignore the minus pi over 3, just draw cosine. Coefficient of X is 1, you can just draw the normal cosine curve. Actually, let me see what's the values of X they restricted it to. Okay, no restriction on X, just draw the normal curve, yes. And equals negative 1, so there's only one intersection, which is
180. I mean pi.
radians, is pi radians. Okay, so is it X that is pi, or is it X minus pi over 3 that's equal to pi?
Like that.
Yes, correct. It's X minus pi over 3 that's equal to pi. Think of it like you replace you have cosine X minus pi over 3 equals negative 1. You replace it with a capital X equals negative 1. Then the graph that you just drew was a capital X against Y. Okay, then you draw Y equals negative 1. Intersection over here is X equals to pi. Sorry, capital X equal to pi. So capital X equal to pi, but capital X actually is little x minus pi over 3. So therefore, solving, you get pi plus pi over 3. 4 over 3 pi. Make it look nicer. Okay, can? Now, next part, solve the equation blah blah equals negative 2. Yes, just substitute straight away. Root 12 cosine something equals negative 2. Right. Continue.
Okay, this one can just divide root 12.
This time it's not +1, it's not -1, it's not 0. Go ahead and use your calculator, your cosine inverse.
Well, cosine inverse negative 2 over square root 12.
Oh, sorry. Before that, one more thing. You forgot about your alpha. Your cute little fish. Wait, what's alpha?
Positive. Wait, what?
How to find alpha? What's alpha? Basic angle.
Cosine.
Reference angle. Always find your alpha. The fish very sad. You forgot about the fish.
Over root 12.
Yeah.
Is it not? Wait, is
yes,
it not?
Correct. Then you type in the calculator. Yeah. Just now you are cosine inversing the negative 2 over 12 2 over root 12 straight away, which is wrong.
Yeah.
First step, always ignore the plus or minus, take the positive cosine inverse. type in the calculator. What do you get? We want radians, by the way. So make sure your calculator is in radian mode.
I get
You get this? Let me know if you don't. Radian mode. Shift setup, then number 4 radian. If you're using Casio, the old version of Casio.
what? Is this a trick?
Why? 0.95531 radians. Wait, one trick. What do you mean?
Wait, why?
There's no trick. Sorry. Did I confuse you with anything?
No, I believe you. Okay.
Yeah. If you want, you can convert into degrees to convince yourself.
Okay.
Yeah, it's around 54.735 degrees, which is acute, less than 90 degrees, as expected. Right, as expected. Around 53 times 180 over pi. But anyways, how do you continue after you find alpha?
Cosine the thing is negative, so ASTC.
Yes.
So it's either
where's my A? Where's the S?
it's either second or third quadrant.
Can you fill in the blank? Tell me, convince me you will remember.
I don't.
A is on the
Top.
top left, top right. Top right. S? Okay, you got it. S. Good, yes, cosine is negative. So which one do you look at? A and C? Do you look at A and C?
No.
When it's negative? No, you look at Isu, huh? So how? What's the angle? Ribbon diagram, remember?
Yeah. Pi
Bow tie.
minus 0.95531 or pi plus 0.95531.
Yes, very good. Okay, how do you get to this quadrant 2 angle? It's 180 degrees, which is pi, and minus away that small angle. Okay, the alternative is you travel this angle already, and then you subtract away. Sorry, you travel pi and then you add on a little bit more to get to this angle. Okay, good. Yes. Sometimes the question can be trickier because there's an x minus pi over 3. So you may need to find additional answers. So in this case, you'll have to add 360 minus 360. Remember this idea?
Mm-hmm.
And when the coefficient is 1, you only need to, you usually only have 2 answers. What if its coefficient is 2x? Cosine 2x minus pi over 3. Everything here changed to 2, but what else do you need to find? You need to plus 360 or plus 2 pi, remember?
Yeah.
Yeah, plus 2 pi. So you get a second pair of answers. Coefficient is 2x, you have a second pair of answers. What happens if it's 3x then? How many pairs of answers do we have? Just now 2x got 2 pairs, so 3x got 1, 2, and a third pair. So you have to plus 2 pi here, and then you plus 4 pi there. Right? If this was a 3x. Then after that, you have to bring the constant over, then add the pi over 3, bring the constant over. Then after that, you divide by 3. Okay? So on and so forth. But for now, don't need so complicated. This is good enough. That's actually for all that. You're assuming that the domain of the x is of the angle x is between 0 to 2 pi. Okay. Otherwise, that trick doesn't work. 2x, 2 pairs, 3x, 3 pairs, 4x, and 4 pairs. That trick only applies when it's 0 degrees less than x less than 2 pi. 2x cosine 2x, 2 pairs of answers. Cosine 3x, 3 pairs of answers. So on and so forth. Obtain by adding multiples k times of 2 pi, where k is whole number. Whole number. Okay, so plus 1 times 2 pi, plus 2 times 2 pi, which is 4 pi, plus 3 times 2 pi, which is 6 pi. Okay, anyways, yeah, you just have to solve for x. I will leave you to solve on your own. Is that okay?
Okay.
I'll just use a calculator. This one cannot use exact value. Okay, then just make sure you restrict the domain to only you must look whether your answer is it between 0 and 6, more than 0, less than 6, strictly for both. Have to reject some of the answers. Maybe. Not sure. You have to figure out yourself. Can? Okay, very good. Moving on. Question 11. Oh, I see already 10:40. Oh. Let me just try and at least finish up this paper too. Okay, 11 part 1 is fine. Good. You differentiate 2x squared minus ln x. You get 4x minus 1 over x. Part 2 you cannot solve with part T. Part 2 cannot solve part 3. Error carry forward. Okay, let's see. So let me just quickly differentiate this. dy by dx is the gradient function. You get a 4x minus 1 over x. Good. Then part 2, the curve touches the positive x-axis at point t. Find the coordinates of t. So that just means that the graph looks something like this. It will be tangent at to the x-axis. So over here, lucky for you, because after you differentiate ln, you end up with 1 over x. So that means that if you want to find turning point, what do you have to set? dy by dx.
0.
0. That's start. Right? Here, don't need the table. Just equal to 0, then solve. So 4x minus 1 over x equals 0. You can rewrite this as 4x over 1, then multiply by x at the top and the bottom. You end up with 4x squared minus 1 over x equals 0. When you have a fraction equal to 0, you can just immediately realize numerator equals 0. Why? Because divide by x, bring over becomes times x. 0 times x, you just end up with 0. So numerator equals 0. Is that okay? Yeah. Then from there, following so far?
Yeah.
Yeah, bring the minus 1 over, you get plus 1. Then x squared equal to 1/4. Take a square root. You get
plus 116.
Plus
hey,
minus.
wait. Yeah, plus minus half.
Right? Okay, square root 1/4 is half. Can? Very good. Okay, can. So what? So that means that we want to find the coordinates of the point T. But point T touches the positive x-axis at point T. Which one do we have to reject?
Reject negative half.
Reject x equals -half. Why? Because positive. Positive x-axis means your x coordinate has to be positive. So this is our 1/2. So for our coordinates of T, in this case, it's touching x-axis. So what do you think is the y coordinate?
0.
Has to be a 0. Good. That's it. That's your point T. Moving on. Show that C equals -ln 2 over root E. Okay, can. So what we have is a point over here, right? Half comma 0, x comma y.
Sub y equals 0 and then sub x equal half into y equal x. Y equals 2x squared minus 1x plus c.
Very good. Yes, exactly. And then you
can
solve already.
The negative ln 2 square root e.
Yeah, good. So that means you end up with ln half minus 2 times half square. Half square is 1/4, 2 over 4 is 1/2. Ln half is something, I don't know. Oh, can bring it up. So become 2 power negative 1. Oops, 2 power negative 1. Can you see what's going on? Then bring down the power negative 1 times of ln 2 minus 1 half. Is that okay? Good. So this is negative ln 2 minus 1 half. Oh, something is a bit off. Let me see. Did I do something wrongly? Negative ln 2 times square root of e. Oh, sorry. I misinterpreted the notation. Sorry, this is what they meant. Negative ln of 2 times root e. Okay. So let's take a look. You have a negative sign here, so I can factor out negative. I'm left with ln 2 plus 1 half. Do you agree that 1 half is really just 2 power negative 1? Yes. Okay, good.
Yeah.
Then do you also agree that ln of e power x equals to x?
Yeah.
So that means that ln of, let's see, e power 2 power negative 1 is also equals to 2 power negative 1.
Yeah.
Can I replacing the x with 2 power negative 1? Okay, good. So that means that we can replace the half here with ln of e power 2 power negative 1. Can see? Okay, good. So that, let me think. This seems a bit odd. Hold on. Might have done something wrongly. I sum in the x with a half square 1/4, 2 over 4 is half. Bring it over negative half. Minus 1 bring over become positive 1 half. Right. Right. Okay. Let me think a bit. Plus a half. Right. Okay. I might be thinking a bit too difficult, a bit too complicated. I don't need to replace the x with 2 power negative 1. Sorry. A lot simpler. A lot simpler. I can actually just replace it with a half. I mean, don't need to replace the x with a 2 power negative 1. I can just replace with a half. Is that okay? But e power half, isn't that just a square root? Power half is square root, right?
Yeah.
Right? Okay, good. So actually I can simplify this a bit more into just ln square root e. Okay? Very good. So ln plus ln, what do you get? Ln a plus ln b gives you?
1 EB.
Which is, in this case, 2 root e. And then we are done. Ta-da. Shown. Can?
Yeah.
Okay, very good. Okay, let's continue. Part 4. Now, find the value of d2y by dx squared at point t and hence determine the nature of point t. Okay, Ken. So we already found first derivative, dy by dx. Let's just recycle that. How do you find d2y by dx squared now? Just differentiate. So let's see. d2y by dx squared equals 4 minus this one, 1 over x can rewrite as x power negative 1. You differentiate 1 over x. What do you get? You end up with, if you use this x power negative 1 format, bring down the o power minus 1 to get the deal. Then you differentiate the inner function x, which is actually just 1. It's just equal to 1. So I'm just purposely using chain rule to convince you that chain rule can be used everywhere. Okay, anyways, you end up with -1 over x squared. Can?
Yeah.
Okay, that's differentiating 1 over x, you get -1 over x squared. But you have a double negative, so this becomes a positive.
Positive.
Yeah, 1 over x squared. Huh? Okay, good. So what? Find the value at t. Value at t. Is this a value? No, it's a function. So what do you need to do to get a value, a number?
Sub in
At t, right? What was the coordinates of t again?
something 0,
Let's see the graph.
half.
Half. So all you need to do is to substitute.
How is just 8?
Substitute. Yes, that's it. Just substitute x equal half. That's all they're asking you to do. Okay, this is the notation for substitute.
So it's a minimum point.
Let's see. Hold on a second. Half square 1/4, 1 over 1/4 is 4. 4 plus 4 is 8. Yes, which is bigger than 0. Therefore, it is. Wait, what do you say? Max or min? 1 and 0?
Minimum.
Minimum point. Okay. Sad face. Sorry. Happy face. Okay. Good. Very good. That's it. Paper 2 done. Sorry?
No. Is no.
Huh? Sorry, you have a question?
No.
Okay. Paper 1, let's see. Okay, you already do halfway. I'll just mark it. Let's see. Haven't had enough time to read it. What do you do? Find the set of values of a constant k for which y equals kx minus 2 meets the curve. So you just sub in the y with kx minus 2 x squared equals 4x minus x squared. Open up the bracket a minus b bracket square a squared minus 2 times kx times 2 plus 2 square. Okay, good. So bring the x square over, get k square plus 1 bracket x square minus 4kx minus 4x is minus 4 minus 4k times x plus 4 equals 0. Okay, b square minus 4 is more than 0. Here meets a bit ambiguous.
Yeah, yeah.
I think it's also a bit ambiguous.
Yes.
Okay, I'll take it as I'll accept your answer. Just cut at 2 points. Cut twice. Cuts twice. It could mean it's tangential, but if it's a tangential, what does it mean for your b square minus 4ac? Touch once. What equals? B square minus 4ac equals to
0.
Okay, you got it. You understand the concept? This one, the English word not good. Meets is not clear enough. Okay, but I'll accept your answer. Okay, just cut 2 points. Then you just calculate b square minus 4 times a times c. There's my a. There's my b. There's my c. Sub in accordingly. Good. This is, let's see. Change it to a plus sign because it works as well. 16k square plus 2 times 4 is 88432. Okay. Plus 4 square 16. Okay. K square plus 1 times 4. Bring in. 4k square plus 4. Minus 4 times 4 is minus 16k square. Minus 4 times 4 is minus 16 times positive 1. Okay, good. And then the 16k square cancel, plus and minus 16 also cancel. Left with 32k more than 0, divided by 32, you get k more than 0. Okay, good. Next. Given that 2x squared plus bx plus c is always positive, write down and simplify the relationship between b and c. Explain why c is never negative. Okay, so this is always positive. Good. So that means b squared minus 4ac less than 0. Very good. You remember. So here, positive coefficient means that it's a happy face. But in order for you to be always positive, it means you must be floating above the x-axis. If you float above x-axis, do you have roots? Roots?
No.
No roots. No roots means that b squared minus 4ac less than 0. Okay? Very good. Then you just sub in accordingly. Here the a, here is the b, here is the c. Okay, so B squared minus 4 times 2 times C is okay. 4 times 2 is 8, so minus 8C, okay. Solve for C. Yes, this is fine. And because anything square is more than or equal to 0, that is good. C must be positive, yes. This is a positive B squared divided by a positive 8. Positive over positive is always positive. The other extreme case is if B is equal to 0, right? If B is equal to 0, then you end up with a 0 square over 8. But it's impossible. If B equal to 0, it's impossible. Okay. Do you know something called proof by contradiction?
No.
Okay, let's just do a quick explanation. Proof by contradiction requires you to start off with a statement that you want to prove. I want to prove that B is never equals to 0. Okay, so I do step 1, I assume the opposite. Assume opposite for the sake of a contradiction. For sake of a contradiction, FSOC. So let's assume that B is exactly equal to 0. Okay. So what happens if B equal to 0? Let's see what happens. Well, we have the expression here, y equals 2x squared plus bx plus c. So that means y equals to 2x squared plus 0x plus c. This gives you 2x squared plus c, right? Here they tell you that this expression is always positive. What does it mean to be always positive? Means this guy more than 0, right? Okay. But what do you know about x squared? X squared is more than or equal to 0 in general, right? For all x. So what happens if you times 2 to it? It's still more than or equal to 0, yes?
Yeah.
Okay, then in this case, if you have this 2x squared more than or equal to 0, you have 2x squared plus c is more than 0. What does it mean? It means that your c cannot be less than 0. Cannot be less than 0. Your c has to be more than or equal to 0, right? Okay, good. How do we get a contradiction? Let's see. Actually, you know what? Sorry. Let me correct myself. I cannot do a proof by contradiction. No. There's no contradiction.
Ooh.
Ooh, sorry. Bad example. This is just a separate case. Sorry. Over here, I was saying that if B was equal to 0, it could be 0 squared over 8, which is 0. Oh, but that's actually also fine. That's also actually fine. Because C is more than 0. So it still answers the question, never negative. Okay? Yeah, okay. So this always works. Your answer is very good. Okay, moving on. Stop me if you've got questions. Okay, let's see this. Question 2. Given that theta is an acute angle and sine theta equals to m, expressed in terms of m cosine of theta. Very good. You remember the right angle triangle. Label m there. Sine theta equals to m opposite over hypotenuse m over 1. So sine theta equals opposite over hypotenuse equals to m over 1. So that means that the adjacent length here is 1 squared plus m squared. Wrong. Oh no. Short side minus. Remember.
Oh, one square minus m square.
Yes, 1 square equals to m square plus, let's just call this x. M square plus x square. Solve for x square, you get 1 square minus m square. Solve for x, you get square root. Okay. Here, how do you tell whether you need to take plus or minus square root? Remember, when you take a square root, you need plus minus?
Positive value length.
Why? Wrong. No. This is not just this is a trivial question, so you cannot take it literally. What you need to do is to check the theta over here. Theta is acute. Okay, so that means that you get sine of theta, an acute angle. What is the sine of m? Sorry, the sine of m. I mean the sine. Plus or minus.
Positive.
Has to be positive. Okay, good. So in that case, if it becomes positive. Actually, is that a main point? Not really a main point. The more important point is actually theta is acute. Then cosine of theta, what's the sign? Acute angle is also positive. It has to be positive. So cosine means you need adjacent over hypotenuse. So it will be x over 1. In order for you to be positive, you need the fraction to be positive over positive or negative over negative. But denominator here, 1 is already positive. So what does it mean about the numerator? It must also be positive. Right? That's how you deduce that the x has to be positive. So you reject the negative square root. Reject x less than 0 because cosine of acute equals to x over 1 is more than 0. Can? Okay, good. So that means it becomes positive square root 1 square minus m square. So now if you take cosine of theta, it becomes adjacent over hypotenuse, which is x over 1, which is then square root 1 square minus m square over 1, which is just square root 1 square minus m square. Positive sign because it's acute. With me so far?
Yeah.
Following. Very good. Part 1 is fine. Part 2, cotangent theta. Here, cotangent is 1 over tangent. You already got the error carry forward. This one is just 1 square minus m square. Cotangent is 1 over tangent. Tangent is opposite over adjacent. So opposite over adjacent. Can you see my highlighter? Opposite over adjacent. So m over square root. Okay, this one error carry forward. Square root 1 square minus m square. Then that becomes square root 1 square minus m square all over m. Okay? Okay now. Very good. Also here it's a positive sign because theta is an acute angle. Yes. So that means that the tangent of acute angle will always be acute angle is Q1. Always positive. Very good. So that's why you do not see a negative sign. You don't see a minus sign. What happens if let's say I give you theta to be more than 90 but less than 180? Then what will be the answer to tangent theta?
Negative.
Negative what? Look at the diagram. Oh, sorry, not theta, m. Yes, it's theta. Oh, I just realized we made a mistake here. This is not m, this is theta. The angle must be theta, not m. Okay?
Yeah.
Right. Yeah, the length is m. Okay, so tangent theta is what? Opposite over adjacent. So opposite is m, adjacent is square root 1 square minus m square. But what do you need? M is positive, square root is positive. If theta is more than 90, less than 180, that's quadrant 2. Only sign is positive, so tangent must be not positive, but rather it should be
Negative.
negative. So you need to put down a minus sign. Okay? Because m here is more than 0. M here is more than 0. This square root here is also more than 0. Positive over positive, that doesn't give you the negative sign, so you have to put in your minus sign. Okay. The way that I usually teach you, draw a right angled triangle, then use ASTC to figure out plus or minus. Understand so far? Recall your trigo?
No.
Yes, you remember. Okay, we'll see in part 3 now. This one really testing your understanding. You have now another acute angle alpha such as tangent theta minus alpha equals to negative half. What can be deduced about the size of theta relative to alpha?
Oh my gosh.
So you start off with tangent theta. So let's say theta is acute, right? So maybe something like this. Theta is here. Tangent theta, I don't know, something. Let's just call it ABC. sorry, let me check something. Theta is an acute. Okay, we have to use back the same diagram. M, X, and 1. Okay, I'm just gonna copy your diagram, copy your triangle with the modification theta and square root 1 square minus m square. Okay, so what? So let's think about it. Maybe it will be better if we just draw the x and y axis version. So there will be a theta over here that's acute. Then we subtract alpha, which is also acute. Now this alpha could have a size that is either smaller than, bigger than, or equal to. So let's consider the three cases. Alpha is smaller than theta. Then theta minus alpha, how would you visualize that? If there is my theta minus alpha, do I turn anti-clockwise or clockwise?
You turn clockwise.
Clockwise. So from here, you have to turn clockwise. If alpha is less than theta, where will you turn? Can you draw for me the alpha, the amount of angle you have to turn? For example,
Alpha is less
than theta.
You'll be in between.
In between, yes. Can you draw for me?
It is not
alpha less than yes. Where's my alpha? Label the angle alpha. Yes. Okay, very good. Yes, you got it. Let me draw it nicely for you. Over here, you turn by a alpha angle. Okay, then as a result, this remaining angle here is theta minus alpha. Okay, good. So let's consider another case. If theta is equals to alpha, sorry, alpha is equals to theta. Well, then in that case, it's just 0. Wait, can I remove your diagram?
Yeah.
Okay. Well, if it's equal to, you get y is equal to 0.
Yeah.
Yeah. Okay. So, but let's just use the same logic of turning around. So turn by the same angle. So you end back. So you end back up where? You end back up at here. Sorry, not back. In a brand new location already. End up here, right? Where the angle whoop, whoop, equals to 0 degrees. Okay, it's just 0 degrees. Okay, no angle to talk about. Now we consider the last case. What do you think it is? Less than, equal than? Less than, equal? Less than 10 equals to 10 or? Less than already mentioned. What's the last possibility?
More than.
More than alpha, more than theta. So let's draw the diagram. How does theta minus alpha look like now?
It will
Again,
pass the 0 degree.
Can you draw for me? Ooh. Yeah, the line needs to be starting from the center, but I think you get what I'm saying, right? Like it will be somewhere like here. Not a horizontal line, right? It's an arrow. Yep, it's sort of like a broomstick. Like a broomstick here. Then you're turning it around, turning it anti-clockwise or turning clockwise. Okay, so here, the broomstick must be fixed at the point, at the center point. Okay, very good. So now you have to rotate by alpha degrees. So over here, alpha, and as a result, the resulting angle there is theta minus alpha. Can you see the blue angle? This part, and it's a negative value. So they tell you that tangent theta minus alpha equals negative half. Actually, it's a trick. You don't need to care about the half. You just need to care about the minus. So which of the three scenarios do you think is the case where tangent theta minus alpha equals to a negative value? Remember your ASTC. All science teacher crazy. Add sugar to coffee. When can you have a negative tangent in these three scenarios? Look at the black line.
And have
This is in quadrant 1. This is
in quadrant 2 and 4.
Quadrant 2 and 4. So which possibility? This one, or this one?
The last one.
Only the last one allows you to have the possibility of tangent being negative. So it has to be the last one. So the answer to the question is alpha is more than theta. Ding, ding. Understand?
Wow. Okay.
Right. If you can understand this, you really understand how angles work in x and y axis already. Turning anti-clockwise positive, turning clockwise positive. Turning anti-clockwise, let me better write it down. Anti-clockwise, this will result in a positive angle. Whereas if you turn clockwise, it will give you a negative angle. Okay. Just turn the broomstick around. Turn. Yeah, turn 10 degrees anti-clockwise, turn 20 degrees clockwise. Where do you end up? Negative 10 degrees. That kind of thing. Okay, part 4. Given further that tangent alpha equals 3/2, show that tangent theta equals to 4/7. Hence, find the value of m.
Alpha equals to tangent inverse 3/2.
No, cannot. This one,
No.
they want you to use the 10a minus b formula. Trigo identity, just to save time, I'll recall it for you. 10a minus plus minus b is 10a plus minus 10b all over 1 minus plus 10a 10b. Okay, right? Good. Then how to use? Tangent theta minus alpha.
Tangent theta minus alpha equals to tangent theta minus tangent alpha, and then over 1 plus tangent theta tangent alpha.
Very good.
Sub in tangent alpha is 3/2.
Huh?
Wait.
Oh, okay, correct. Oh, oops. Let me just do some more.
Can sub tangent theta minus alpha equals to negative half.
Yes, very good. Negative half as well. That's what I'm waiting for. Okay, but then tangent theta is 4/7. Then just sub in as well. I don't know if you mentioned that. I couldn't hear you. Then tangent alpha now becomes 3/2. Let's see. Equals negative half. Okay. Did I do something wrongly? I get number equal number. Sorry, you're supposed to show that tangent theta equals 4/7. You didn't know it's 4/7 yet. Show that. So this should remain as a tangent theta first. Is that okay? Okay, very good. Then from there, you can cross multiply. It might help if you replace the tangent theta with an x. Okay, if you are not familiar with the trigo expression, you can rewrite this as x minus 3/2 all divided by 1 plus 3/2 times x equals negative half. Okay, good. Then now you cross multiply. This part here, oops, crossover. That part there, crossover. So we end up with 2 bracket x minus, let me standardize the x, capital X, minus 3/2 equals to negative 1 bracket 1 plus 3/2x. Okay, so on and so forth, you'll eventually get to x equal 4/7. I will leave you to do this as a homework.
Okay.
Can? This one can solve, can. Just algebra. Okay, hence find value of m. So how? What do we know about the Okay, now that we have shown tangent theta equals to 4/7, how do we link it to m? That's when you have to use your previous part. So tangent theta, which one is related to tangent theta? Everything is related lah. Trigger all of the identities, but which one is more directly related? Part 1 or part 2?
Part 2.
Of course, it's part 2. Because cotangent is 1/tangent. So that means that we can use the answer we got from part 2, which is this guy over here. Okay, that is the answer from part 2, right? This is cotangent theta. How do you find tangent? From
M
cotangent?
over square root 1 minus m squared.
Very good, exactly. So this is just m over square root 1 minus m squared equals 4/7. Homework, solve for m.
Okay. I like that.
Yes. Okay, so but this is the main point. The rest is just algebra. You can do it.
Yeah.
Okay. Question 3. This one, just one careless mistake over here. Your working was perfectly fine. For y, wait a minute. Y equals to 3 terms over here.
Yeah.
1, 2, and 3. You saw the mistake already. Look carefully over here. For y, what did you do? What did you do? I have yellow. I have green. Where is my purple?
Okay, I didn't sub in the minus half sign to x.
Yes, correct. If you sub in, then you can use CF convert to go and compare coefficients. Okay, you were asking me just now. Yes, you can. Okay. Yeah, error. That's just a careless mistake there. Then carry on. Redo.
Is B 1/4?
I don't know. You can check the answer key. Yes,
Wait.
I think so.
Will you cancel the sine 2x that's there? The 2 sine 2x that's there?
Yes, it will cancel away.
Oh, so A is 1. Both of them is 1/4.
I'm not sure about B. Let me see.
Both of them.
Right. I'll leave you to work it out on your own.
Both of them.
I've given you enough hints that you can solve.
Both of them.
Let's compare. Okay. Very good. Done. Please finish up paper 1 and okay. Then try. Yeah, finish up paper 1. Then if you got extra time, you go and try the AMP. This one. Anderson. ASS.
I think A and B is both 1/4.
Yes, I think so too. But you can show me the working if you need. Okay, you haven't tried binomial expansion. So try paper 1, then later on try ASS paper 1. Try paper 1 first.
Okay.
Okay.
But you know why I did paper 2 first? Because I looked at paper 1, then I was like, oh no.
Okay.
Then
Oh god.
I was like, yeah.
That's the point of the revision paper.
I was like, oh no, this
Then you must try the ones you don't know, then you ask me, that would be more relevant, more useful. If you already know it, what's the point in doing it again?
Feel
okay.
good.
I'll revise. Okay. Yeah, I guess that is value. But okay, that's all for today.
Thanks.
And thank you. Bye. Let me know if you got any questions.